Hello everyone, welcome back to my channel. I am Kaustav Datta, USN 1VE23CS082, Semester 2nd, Section BMW. So the topic of today's video is computer graphics for the subject Mathematics 2 for Computer Science and Engineering stream, bearing the subject code BMATS 201. Introduction to Computer Graphics. Computer graphics is the art and science of generating visual content on a computer. It encompasses a wide range of techniques and technologies from 2D image manipulation to 3D modeling and animation, all of which have numerous applications in engineering and mathematics. Fundamentals of computer graphics: raster graphics, vector graphics, and color model. Raster graphics. Raster graphics represent image as a grid of individual pixels, each with its own color and intensity. This approach is commonly used in digital displays and images. Vector graphics. Vector graphics use mathematical descriptions of shapes, lines, and curves to create image. This approach is useful for scalable resolution independent graphics. Color model. Understanding color model like RGB and CMYK is essential for creating and manipulating digital images and graphics. Rendering techniques. Rasterization. Rasterization is the process of converting vector graphics into a raster image by determining the color of each pixel. Ray tracing. Ray tracing is a rendering technique that stimulates the path of light rays to produce realistic images with reflection, refraction, and shadows. Photon mapping. Photon mapping is a two-pass rendering algorithm that simulates the transport of light energy to produce global illumination effects. Progressive rendering. Progressive rendering is a technique that gradually improves the quality of an image over time, allowing for fast initial display. 3D modeling and geometry. Polygonal modeling, subdivision surface, NURBS modeling. Polygonal modeling. Polygonal modeling uses a mesh of interconnected vertices, edges, and faces to represent 3D objects. NURBS modeling. NURBS, or non-uniform rational B-splines, are a mathematical representation of 3D geometry that allows for smooth continuous surfaces. Subdivision surface. Subdivision surfaces are a hybrid approach that combines the flexibility of polygonal modeling with smoothness of NURBS. Lighting and shading. Lighting models such as Pong and Blinn-Pong simulate the interaction of light with surfaces to create realistic illumination effects. Shading techniques. Shading techniques include flat, Gouraud, and Phong shading. Determine the color and brightness of each pixel based on the lighting condition. Shadow mapping. Shadow mapping is the technique that uses depth information to generate shadows, adding realism and depth to 3D scenes. Global illumination. Global illumination algorithms such as ray tracing and photon mapping simulates the complex interplay of light in a scene for more accurate lighting. Texture mapping and materials. Texture mapping. Texture mapping is the process of applying 2D images called textures to the surface of 3D models to add details and realism. Material properties. Material properties such as color, reflectivity, and roughness define how a surface will react or interact with light and influence its appearance. Shader programming. Shader programming allows for the creation of custom algorithms that determine the final color of each pixel, enabling advanced visual effects. Animation and simulation. Keyframing. Keyframing is a technique where the animator defines the starting and ending position of an object and the software interpolates the intermediate frames. Rigging and skinning. Rigging and skinning is the process of creating a skeletal structure and attaching it to the 3D model to enable realistic movements and deformation. Physical based simulation uses mathematical models to mimic the behavior of real world phenomena such as fluid dynamics and cloth simulation. Application of computer graphics in engineering mathematics. Visualization of complex data. Complex computer graphics can help visualize and interpret the complex mathematical and scientific data, enabling deeper understanding and insights. Geometric modeling. The 3D modeling technique used in computer graphics are essential for designing and analyzing engineering structure and products. Simulation and analysis. Physically based simulation can be used to model and analyze engineering systems such as fluid flow, structural mechanical, and material behavior. Computational geometry. Computer graphics, algorithms, and data structures are closely tied to computational geometry, which is essential for engineering applications. So I would like to thank you all for being with me to the end of this video. If you like the content, then please like, share and subscribe to my channel for more such contents. Thank you.